So today the topic that we are covering is exponents dealing with zero and negative exponents. So let's review the basics of your exponents. If you have something, say 2 to the 4th power, remember that does not mean 2 times 8. Here you've got your base number. That is the number being raised to a power. And this is your exponent or your power. And as I was saying, that doesn't mean 2 times 4. That means you're multiplying the 2 by itself 4 times. Okay, so that is what 2 to the 4th would look like. All right, but we want to get into a power of 0 and then negative exponents. So I want to start with something that we know. For example, I'm going to pick a random base number and raise it to a power. If we have 3 to the 3rd power, we know that that means 3 times 3 times 3 if we were to write it out. All right, and that gets us a value of 27. So what I'm going to do is continue this, and I want to keep the same base number, but I'm going to keep decreasing that exponent by 1. So my next line will have 3 to the 2nd power, then 3 to the 1st, and so on. And what I want you to do is take a look at the result that we have over here and look for a pattern. So if you have 3 to the 2nd, we've got 3 times 3, and that gets you 9. So I want you to compare the previous result with this result here. So if we continue our pattern, we have 3 to the 1st power, which would just be 1 3. So I want you to notice we have 1 less 3 every line. And so we would have a 3 here. So I want you to notice that our base number is a 3. And as we go from 27 to 9 to 3, what's happening is we keep dividing by a 3. All right, we keep losing a 3. We're multiplying by 3 one less time. So if you take your 9, and if you divide that by 3, you get 3. So I want to continue with this pattern right here. If we continue to divide by 3 here, if we take 3 and divide that by 3, the result is going to be a 1 right here. So let's take a look and see what we would be at over here. If we keep decreasing our power by 1, we'd end up having 3 to the 0 power. So anything to the 0 power is going to get you a result of 1. So a lot of people think that 3 to the 0 power is 0. But it's not, because you're following this pattern here and you keep dividing by whatever the base number is that you're using. So I want to keep doing that. Let's keep decreasing our exponent by 1. The next power would be the negative 1st power. So now we're introducing negative exponents. But we know what the pattern is over here. We continue to divide by whatever our base number is. So to get the value here, we're going to continue to divide by 3. So if we take 1 and we divide it by 3, let's keep it as a fraction. We would have 1/3. Okay, think of that as 1 over 3 to the 1st power. So I'm going to go ahead and write that over here. 1 over 3 to the 1st power. So I want you to take a look at the way we had it originally. 3 to the negative 1st power is the same as 1 over 3 to the positive 1st. So this is showing us that a negative exponent doesn't mean we have a negative value. It's showing us that we actually have a fraction. And this is how that would look in fraction form. So we're going to keep taking our results over here and continue to divide by 3. So if we take that 1/3 and we divide by 3, we're going to have 1/3 divided by 3. Remember, that's keep, change, change, flip, keep, change, flip. So we're going to have 1 over 3 here. 1/3 times 1/3 is going to get us a 1 over 9. We know that that is going to be the next result. The next exponent is 3 to the negative 2nd power. So let's look at another way to write 1 over 9. 9 can be rewritten using a base number of 3. That would be 1 over 3 squared, same thing as 1 over 9. So here is the problem written with a negative power. Here's how you can write the same thing using a positive power. If they said to evaluate it, you'd go further and say 1 over 9. But if they ask you to write this expression using a positive power, you know this is a fraction, 1 over 3 squared. Let's go one step further and do a negative third power and see if you can go right away to rewriting this with a positive power. We know it's a fraction. So again, you can come over here and do the dividing by 3. If you take your 1/9 and divide by 3, that's keep, change, and flip. You're going to have 1 over 27. All right, think of how you can write 27 using a power of 3. That would be 3 to the third power. So 1 over 3 to the third power is the same as 1 over 27. But this is how you can show it using a positive exponent and keeping that base number of 3. So anything that has a negative exponent tells you you actually have a fraction. For this value to be negative, your base number would be negative. So depending on what the sign of your base number is and then what your power is. But the exponent does not tell you if you have a positive or negative value. It just tells you if you're a fraction or not. So let's look at the rules that we've come up with so far doing this. All right, the first thing that we noticed, remember we're talking about 0 as a power. Anything to the 0 power is going to have a value of 1. So I'll use a generic base number, use the variable a, raise it to the 0 power. We can replace the entire thing with a 1. Notice the base number is not there anymore. It's just a 1. And then any number to a negative power does not mean you have a negative value. It tells you you have a fraction. Think about it as you can put anything over 1. Think of that as upstairs, downstairs. Wherever your base number is with a negative power, if you change its location, if you move floors, so he is upstairs, if you move him downstairs, you are changing the sign of his power. If nothing is left upstairs, you would put a 1. There's your fraction. And so sometimes people have a question about, okay, what if you had a coefficient in front? All right, what if we had 2a to the negative n power? Think of having an upstairs and a downstairs. Anytime you change floors, you change the sign of your power. But you need to look at your coefficient. Technically, he has a power. He's to the first power. He does not need to change locations. He already has a positive exponent. So the 2 will stay upstairs. Only the a has to be moved downstairs so that you can change his power to a positive. So a to the n. So that's how you would deal with it if you had coefficients involved. Okay, let's try some examples. We'll see what these problems will look like for homework. All right, let's start with something basic. Let's say you have 2 to the negative 6th power, and I want you to just rewrite that using a positive power. So I want that 6 to be positive. Well, you can think about it as upstairs, downstairs if you want. He needs to change floors to make his exponent positive. So you're going to have a fraction 1 over 2 to the 6th power. Now, if they said to evaluate, you would actually then figure out what 2 times 2 times 2 and so on is. Right now, you've written as a positive power. Okay, so let's rewrite this one with all positive exponents. Okay. Well, first of all, I notice that the denominator is to the power of 0. So I know that denominator is going to be a 1, which means you don't even need to put it in your answer for this part. Let's move this guy over. Now I am kind of glad I have the 1 there because I can clearly see my upstairs and my downstairs. Now 6 is to the first power. He has a positive exponent, so he will stay where he is. This is going to become a fraction, and this is going to become a fraction. Both of those need to move downstairs so that the 1, the -1 and the -3 can become positive, which means you are left with the 6 in the numerator. You now have the a in the denominator to the positive first power. The c is in your denominator to the positive third. Writing the 1 there is optional. So that would be your answer to example 2. All right, my coefficient's going to be negative. There's my numerator. And here is your denominator. Okay. So let's think about this. This is a fraction, this is a fraction, so it's going to get a little bit messy if you were to rewrite this as 1 over p to the 8th. Because if you have a fraction in your denominator, it can get complicated. So here's what you need to look at. Just look at everything one at a time. Your coefficient has an exponent of a 1. That -3 is going to stay there. Only the base numbers with a negative exponent are going to change locations. That's the k, he has to move downstairs, and the p is going to have to move upstairs. These two here can stay exactly where they are. They already have positive exponents. So now we have -3. We have the m already, the n already. The p goes upstairs, and now the 8 is a positive. And the bottom now has the k, and his exponent is now positive. So just look at each one at a time and only move the ones with negative powers, and you switch floors. That would be your final answer. Let's do one more for fun. All right, let's switch it up a bit. I want you to evaluate. So your answer is actually going to be a number. We're going to use the variable r. I want him to be a -3. And let's use an s. Make sure it looks like an s. I want him to be a 5. Here is your expression. R to the -4th times s squared. Well, that's it. Let's leave it like that. So you can either plug in right now, or you can go ahead and clean that expression up and use positive powers, then plug your values in. And that, I think, is what I'm going to do. I'm going to pretend that's over 1, so I see an upstairs and a downstairs. Only the r has to move because that's my negative exponent. So the s squared stays up in the numerator. The r is now at the bottom, and it's to the positive 4th power. Now I'm going to go ahead and plug my values in. R is a -3. Anytime your base number is a negative, you need to have that in parentheses so that the negative gets the exponent as well. The s is a 5. You might as well put everybody in parentheses. We're going to square that. So 5 squared is 25. And if you take -3 times -3 times -3 times -3, 4 negatives makes a positive. You've got 9 times 9. You've got an 81. That cannot be reduced, so that is your final answer. All right, so that is going to be our next lesson. And we'll talk about it and answer any questions when I see you next.